Good. Right. Good afternoon, ladies and gentlemen. We're here to talk about the learning engagement for group presentation, which consists of myself, Olayiwola, and Nasmo. Um, we're going to be talking about discrete and continuous distribution for representing the behavior of parameters or variable. First of all, we have to dissect what these uh, things do mean, what these concepts do mean. And we're going to, at first, let's talk about the variables, which simply means a representation of of changing data. It assumes any numerical value as opposed to the one which is a constant, which assumes constant value. So then we will be talking about the discrete and continuous distribution. We've all been acquainted with what discrete and continuous data is. So we're going to be talking about the distribution, which simply which underlines the probability theory as well as the statistical analysis, which are the essence of our class. Discrete distribution, with reference to the University of Florida article 2009, denotes a probability of occurrence of each value of a random variable that has countable values. That is the difference between it and continuous distribution. Discrete distribution has sub-distributions. Let me say sub-probability distributions, which includes Bernoulli, binomial, Poisson, and multinomial distributions. And in understanding the representation of behavior of these variables, we would have to observe how each type represents events. So Bernoulli distribution is the pair of probability of an event for which the probability that the event occur is P, while the probability that the event does not occur is 1 minus P. So that is a kind of representation. It implicitly states yes or no decision process. That's for the Bernoulli distribution. We have a PowerPoint showing the simple representation as well as a complex representation of it. The binomial distribution, on the other hand, represent the success or the failure of a while the Bernoulli distribution represents the success or the failure of a single Bernoulli trial, the binomial distribution, on the other hand, represents the number of successes or failures in n type. That means several types of independent Bernoulli trial. So if we know Bernoulli distribution, binomial distribution is an extension of the Bernoulli distribution, all which falls under the discrete distribution category. We have, I said, we have calculations implying on the representation of this distribution. Because of time, we might not be able to go through this. We have the PowerPoints, which will be presented. Then we have the Poisson distribution, which is the limiting case of the binomial distribution. The distribution can be used. A very important aspect of Poisson distribution is that it can be used to model the number of defects in a manufactured article. It is used for situations where the probability of an event occurring is very small, but the number of trials is very large. So that is the Poisson distribution. While the multinomial distribution is a multivariate generalization of the binomial distribution. All these distributions are extensions that depict the representation of probability distributions of variables. That's as well. Then we have the continuous distribution representation. I used the Duke University Nicholas School of Environment statistical dissertations, which states that which describe the continuous probability of possible values of random variable with a set of possible values that is infinite and uncountable, known as a continuous random variables. All this, the representation, the calculation, as well as the representation, the mathematical representation of it is depicted, briefly depicted in our PowerPoint. But that is the summary of how our distributions represent variables or parameters. Thank you very much. I now hand over to Olaiwola to present more on this.
Thank you, everyone. My presentation today is based on the 4th week learning engagement we're given. I have to research study. One borders on one makes use of district data distribution. The other makes use of continuous data distribution. The first one, the topic is impact of mobility groups on urban travel. A case of London and Berlin. Urban cities like Berlin and London leverage on new choices of mobility. This research was conducted by London School of Economic and Political Science. London and Berlin have fast-growing population and well-developed transportation system that needs intervention through innovation because of extensive economic pressure they are experiencing. The purpose of this study is to examine the residents' behavior in relation to daily travel within the metropolis, and is also to use the change to identify more targeted intervention. The table on display shows the population distribution and growth in 2001 and 2011 in the city of London. London is broken down into inner London, outer London, and greater London. It shows the population. The population is district variable. The table also on the next on display shows shows the use of each type of mobility. We have, apart from some people use public transportation, some drive on their own, others walk, others cycle. We see the distribution, the way the population, the percentage of each of them in the city of London. This is a forecast for traffic growth because in such metropolitan or cities, it is believed that there's going to be a lot of traffic, which is what they are experiencing right now. But then the forecast was that it's going to be tougher than what they are practically experiencing now. The forecast shows, the graph above shows the forecast that they made in 2013, but the actual traffic growth is actually what is on display right now. It is far less than what was projected. In conclusion, it shows that the study confirmed that the attitude-based mobility groups are useful in characterizing the subjective dimensions of travel behavior and the wider choices affecting urban travel. That's the reference. The second research work is on the effects of age and gender on student achievement in face-to-face. Well, face-to-face means in-class learning and online learning in a college or liberal class. This study was carried out in a college in southern Texas, part of the United States of America. The data collected from students are majorly, the students in the school were majorly Hispanic. So most of the data, the larger percentage of the data is about the Hispanic population, while the people in minority are the Red Indians, the Black Americans, the Asians, and the likes. The purpose of this study is to examine the effects of demographic characteristics like age, and gender on student achievement in academic year of 2010 to 2013 as measured by grades. It was broken down into in-line, in-class study, which is face-to-face, or online learning environments. The data distributions here shows the population, the total population used, which is for the whole school as at that point in time, 7,791. The male part of it, the female number, the Hispanic based on ethnicity, the Caucasian, the others, and majorly the continuous variable here is about the age distribution. The age is broken down because age can assume any number. It's broken down into 18 to 20 years of age. It's broken down into male and female, 18 to 20, 21 to 22, and the rest like that. We see the mean value for the age. We see the standard deviation, both for online and in-class learning. The methodology used from the frequency distribution above, age of students is a continuous variable. The data was analyzed using multiple regression to determine how well the variables of age, gender, and ethnicity predicted achievement as measured by the course grade in face-to-face college algebra courses. The predictors here were age, gender, and ethnicity, while the criterion variable was student achievement as measured by final grade for a college algebra course taken in the fall and spring of 2010 to 2013. The results show that the achievement score is measured by final grade of face-to-face student was higher. That is, the mean is 2.98 than for online students, 2.2. It also showed that the average grade of female students was higher than the average grade of male students. It also showed the average age of online students was higher than the average age of in-class or face-to-face students. We can infer from this that the predictor variables of age and gender predicted student achievements in college algebra in face-to-face courses using multiple regression analysis. However, the researcher found that none of these variables could predict the student achievement in online courses. That's the reference. Thank you.
Thank you.
So, hi everyone. So I'm going to be sharing the two dissertation topic for week 4. So yeah, so the first one I got about the property testing and probability distributions by Clement Cannon at Columbia University. In this dissertation, they use the discrete probability distributions by figuring out some of very specific information about their probability distributions. So yeah, it's a very broad report. I put the link of the report. So yeah, and for the second one, second one, they use the continuous and the discrete properties of stochastic process by Wai, Ha, and Lee. So yeah, in this thesis, they considered the interplay between the continuous and the discrete properties of random stochastic process. And also, secondly, it also shown that the spatial cases of the one-sided Levy-Stable distribution can be connected to the class of discrete stable distributions through a doubly stochastic Poisson transforms. And below of this slide, this is the link, and this report was made at Nottingham University. So yeah, those are the two reports which includes the example of the discrete and also the continuous variable. Thank you everyone.